Alright, so what kind of rifle were we working on today?
Working on a Remington 700. I'm going through the processes of getting the action, bolt, and recoil lug ready for accepting a new barrel and trying to get everything straightened up and correct. What we're going to do here is I'm going to true up the inside face, the breech face, where the back of the case actually makes contact. I'm going to true up the front of the bolt nose, the front of the recoil lug, and the backs of the recoil lug, and I'm going to make these surfaces perpendicular to the bolt body. People ask, why do I true up the front too? Because it makes my job easier. As you can see on this one, there's obviously a high spot right here where it's come in contact with the back of the barrel, and it isn't touching over here. What I do is when I make these two surfaces exactly the same, or perpendicular, that means that I can get the bolt that much closer to the barrel, reducing a gap there for dangerous gases to come out in case there's a case head failure, without having a little high spot and low spot that's even all the way around, so I don't have to go to the, we'll call it the weakest link. Then, like I say, I true up the back sides of the bolt as well. And to hold this, I put a driver in here. Now this is just aluminum. It gets returned for every bolt. So I'll hold onto the bolt body, and I'll actually machine turn this section here to where it is concentric to it. So when I flip it around, I can hold on to something to where it's spinning true. The reason I have to do it for every one is because the threads that are cut in the back of these bolts are all different. You never can tell if they're actually concentric to the bolt body, if the back of the bolt is even perpendicular to the bolt body itself. It's a Remington, you kind of get what you get. They make great stuff for just off the shelf and mass production, but we're looking for that next level.
Okay, so what would the next step after this be?
Well, where we're sitting at right now is I'd actually go through and I'd cut this surface like we said.
Okay.
And I can show you that here in just a second, but just to jump ahead, I can give you a visual of what one looks like after it's been trued up. Now, I also went ahead and did a Seiko Extractor install on that one.
Why the Seiko Extractor?
It's a Magnum case, and when you start hot rodding and loading to higher pressures, the factory Remington one has a tendency to fail, but if you stay well within SAMI specs, you'll never have a problem.
Okay.
But I trued up this surface and this one here. The barrel bolt gap now is going to be much easier to get that 5 to 7 thousandths maximum that I like. The counter bore is going to be 155 thousandths because there's the distance that I made it sure that it was at.
Okay. And
you can see here on the back of the lugs that they've been machine trued on a lathe. These aren't just lapped in. Lapping will just make it it knocks off the high spots,
right,
but it doesn't necessarily mean that it's perpendicular. Okay. You can actually overlap and actually make this contact surface on the back at an angle. And that's really not where we want to be. It's perpendicular is for a reason. It's a neutral angle, so when something is pushing back on it, it doesn't want to unscrew it or open the bolt and shove it through the back of your head.
Right, that makes sense.
And you can also see down in here where I machine trued the face. So reloaders and bench rest shooters really like that surface to be absolutely perpendicular because it does not actually bend your brass in the back and cause the back of the brass to actually be shifted off like this. So when you put it in your reloading press, you're reshaping the sides of the body more than the base.
Okay.
If it's straight, it's actually easier on your brass. It's easier to maintain your headspace through reloading, and it's just a lot more cost effective when it comes to start reloading. You're not throwing away nearly as much.
Right. Alright. Well, let's get that thing on there and watch it happen. So this is where you're talking about recutting that, right? Every single time?
Yeah, because you can see right there, or you should be able to see right there, that there's quite a bit of movement I put the red Dicam or light layout fluid on it so you can actually see. And I'll make a light cut over it, and it'll really show up then. You can see by it cutting here and not here that driver is not currently concentric to the bolt body.
I see that.
You might criticize me a little bit for using a 3-jaw rather than a 4-jaw, but this 3-jaw here runs within about 1/1000th of for concentricity. So within realistic expectations, that's well in our tolerances.
Okay.
So I'm going to go ahead and take a bigger cut. Just because all the red is gone does not mean that part is concentric yet. I can still see a little bit of flash in the reflection. And what that tells me is that there's been a little bit of part or tool deflection while I'm cutting. So we'll actually go ahead and take another pass, a real light pass, trying to make this just as absolutely as concentric as we can get it. Once I get rid of this nest. Check one more thing here real quick. Should have done this earlier. Make sure that completely clears. That's off. Another 4,000 should do it. Alright, now that I've got a concentric surface to hold on to, I can still use my 3-jaw because it hasn't been beat up and destroyed. Okay, now what I'm going to do is I'm going to true up the two surfaces that make the counterbore. I try and take just the absolute minimum off here because that's the only amount of material that's going to hold in your extractor unless we upgrade it to a Seiko. So this right here is about 1.5 thou. See by some of the black that's left over that that's still a low spot, but it's below, it's on the outside surface, so it's going to actually part of the relief on the edge of the corner, so it's fine out there. I've gotten rid of all the high spots. Now I'm going to make this surface parallel to the front. And 155 thousandths in length. Make this one a little bit more. As you can see, the lug closest to you comes completely up and cut the entire surface, but that one did not. What causes this is that Remington bolts are actually three pieces. You got a bolt handle, a bolt body, and the section here in the front that's a bolt nose. The bolt nose is pressed in and then welded or brazed, and sometimes they don't get them exactly straight when they do it. Well, this is what we get, but thankfully there's enough material that we can go through and true these up. Now, I just don't like that. It shows absolutely no harm in leaving that like that. I just don't like the way it looks, so I'm going to fix it. There we go. So, now these two surfaces are parallel to each other, so when I cut the counterbore or the 3 rings of steel into the back of the Remington barrel, I can reduce my tolerances down. Now we're going to true up the back side of the lugs. These are the ones that actually matter for the accuracy part. This way the bolt stays straight in the gun through the entire recoil. And again, allows us to get our tolerances even tighter on the head space.
Okay, so overall, what is this going to do for the shooter when he gets his gun back?
Well, what it does is it reduces all the things that could possibly be wrong that makes guns finicky.
Okay.
I found that by doing all these things, getting all the things that need to be parallel, and all the things that perpendicular, reduce the problems with guns only liking one load.
Right.
Now, yeah, you're going to have one load that's going to shoot better than the rest, but there's going to be a lot more acceptable ones now, just because it's not fighting all of these, what's the word I'm looking for?
Different variables?
All these variables or stressors put on the gun by the way it was built.
Okay.
So
essentially, with every single one of these you're taking a factory rifle action and you're basically making it a one of a kind. It's because there's not going to be any one exactly like this one.
No, they're not. They're never going to be exactly the same. But what I'm doing is I'm taking a factory, mass-produced rifle and putting the same care into it as that you see in these really expensive custom actions.
Oh.
Yes, there's going to be some variables in here, not variables, but things that you can get on Defiance actions or Stiller actions and things like that that they're going to have their little knick-knack that they like to put in their stuff. But the reason those actions are so good is because this kind of care was taken when it was first built,
right,
instead of afterwards.
Okay. Alright, so now what are you doing?
I need to come in and actually touch the bottom. I didn't get quite in there quite far enough. full contact surface. Now we do the one that always makes you really stand up and pay attention. I've got to actually reach in now and through the interface behind the extractor. Well, since it's a Remington, coil spring type extractor, I can't take it out without ruining it. So I have to literally reach in behind it, cut behind it all the way out to the firing pin hole without ripping it out of the
Alright, so what do you have this set up to do now?
Okay, now I'm actually going to true the breech face. This part that actually comes in contact with your brass.
Which is inside, right? Is that what you're talking about?
It's on the very inside where the firing pin comes through.
Okay.
Now, there's a high disaster factor here. I do the wrong thing, turn the wrong handle, the extractor comes out, and then I get to put a Seiko extractor in for free.
Outstanding. I'm sure the guy wouldn't mind.
No, I'm sure they wouldn't mind at all. But this is probably one of the reasons why a lot of gunsmiths would rather just change the bolt out to a new bolt from like Pacific Tool and Gauge or something like that.
Right.
I don't really see it necessary. All you have to do is just do it. So we're going to fire this up and take a truing pass on there.
Okay.
Make sure we got all the way to the outer edge. I'm going to reach in there and take a few more thousandths on the width. But as you can see now, the face is actually trued up and now perpendicular to the bolt body. And it's parallel to the back of the lugs. So now the case is getting pushed on straight while it's in the chamber.
Right.
And there we go, all the way out to the edge. That bolt is now trued up.
Nice. So what's the next stage?
Now we move on to truing the receiver to accept this nice new bolt we have.
All right, so what are you messing with there?
It's a factory Remington recoil lug. They come in all shapes and sizes. Most of them are actually shaped like a door wedge, meaning thicker on one part than another. This one here I measured just a second ago, it being about 1 thou to 1 thou and 2/10 from being parallel, the two sides being parallel. And what that means is, let me get it pointed around the right direction here real quick, is that if the action was on this side, when the barrel gets put on, the barrel would be pointed for this one up and to the left.
And it came stock like that?
And they come from the factory that way. Now granted, I showed a huge amount there, but when you consider 1/1000ths over less than 1/4 of an inch, think of it,
huge difference.
Think of it exactly like, building anything with a level, a 1/4 inch over 12 inches of angle is not very much, but now take that and shrink it down to something that's only a 1/4 inch long, and
Right.
that's where downrange it starts to get a little wonky. You start wondering why you're one way left, or sometimes left with some guns, sometimes right, or that you don't have to dial up as much for certain ranges. It's just because of the way the barrel's pointed underneath the scope.
Okay, so now what are you going to do to that one then?
What I'm going to do to this one is I'm going to set it up on a surface grinder. You can see the difference in the surface finish, and actually grind both sides to where they're parallel.
Huh.
I measured this one around here just a second ago, and this one measures within 2/10 of 1/1000th of being parallel all the way around. And that's with a veneer mic, not a set of electronic calipers.
So
These are accurate.
more accurate than the calipers.
These I can make you get whatever measurement you want just by how hard I push on them.
Okay.
So this one's as close as that I can possibly get it to being absolutely parallel without going to NASA, doing everything in a controlled temperature room.
Right.
So
Okay.
now that we've
We'll
got
check
this
that out
bolt
now.
all nice and trued up, now we got to have something to put it in. Factory Remington receivers are made just like their bolts, mass produced. It's good enough, but we're looking for that next step again. So the surfaces that I'm really critically concerned about are this face here, because the recoil lug sits up against there, in between the barrel and the receiver. I've taken all the work into making my recoil lug parallel. Now I want this to be worthy of that. So we got to make this absolutely, or as close to perpendicular as we possibly can, so we got the barrel screwed on straight. The next thing that we need to do is down inside you'll see the 2 recoil lugs. That's what the bolt actually holds on to keep the bolt from coming out and going through the back of your head. Now, there are so many different schools of thoughts on threads. There's all sorts of tools to go through, single point or piloted tools to retap these receivers to make the threads perpendicular or concentric to the bore line. I understand this. Those are great tools. Personally, I think a lot of it at that point when you're talking about threads justifies an added expense to a job. This is just my own personal theory. So what I do is, in case of the threads inside the receiver, I treat them just like I do the bolt nose. What I want to do is get rid of all the high spots so my threads will fit better into the receiver.
Right.
So just like I remove the high spots off of here and there, all I do is take a good quality tap and run it in there. And as you run them in there, you'll actually see and feel high spot, high spot, high spot. Goes around and it's loose. Now you see another high spot to where we actually will end up cutting.
So you're cutting those high spots down.
I'm just cutting the high spots off. I'm making the threads uniform all the way down to the bottom. That way when I thread my barrel on a single point on the machine, the threads don't change. The tolerances of the threads don't change as we go in. Some of these things like this one here, as you see, is getting tighter as farther I go in. Think of it as like a pipe thread. It gets tighter until it stops because it's tight, not because you've actually bottomed out on anything.
Right.
Well, I was taught that these shoulders here, the outside surface, both sides of the recoil lug, and a surface that's on the front, your front shoulder, when you thread this, you'll have a shoulder up here in the front. Those are the important parts. That ensures that everything's pointed in the same direction. It's not pointed up, not pointed down, not pointed left, not pointed right.